Okay, we want to talk a little bit about linear models. We haven't really talked about linear functions. We could let y equals x be another basic function. And by relabeling y equals x, we can get any linear function. Pretty much, sort of. Okay, if we want to flip it upside down so it has a negative slope, well, like it's going to have here, then the relabeling goes just a little differently, but not going to worry about that right now. Let's just draw a straight line that we think, ooh, that's not going to be good. Okay, kind of had to change the direction there. Okay, this one might come pretty close on the average to the 4 points. Closer maybe than it would be if you had a slightly different slope, but I'm sure that by a slight adjustment of the slope one way or the other, we could improve the fit. Or by raising it or lowering it a little bit, we could probably improve the fit in the sense that the line would get closer on the average to the 4 points. Now remember, we're really wanting to do the average of the squared distances, okay? But that's a little hard to see. We don't want to get into that, so we're going to leave that alone for now. Okay, well, there are many ways then to get the equation of the straight line you have, but the excuse me, the method that I want to advocate at this point, not because it's always the best method, then let me back up. You probably know, y equals mx plus b, y minus y1 equals m times x minus x1. Those formulas for the equation of a straight line. Those are formulas. If you don't understand what they mean, then it's just a formula. Okay, so we're going to do something else here, and you might not totally understand what it means either. Now there's one way to do the equation of a straight line that has a lot of meaning, and I'm going to show you that too. Okay, the linear model, excuse me, is going to be done by taking 2 points on the graph. Now people always want to take 2 of the data points, but the graph doesn't even go through the data points. You never expect the graph to go through the data points. So if you choose 2 data points, you've ignored all the others and the effect they have on where the graph is going to be, on where the best line is. And that's totally unacceptable. Okay, so we draw the best line, and we mark 2 points on it, and we estimate their coordinates. So this point has a coordinate over here. This point has a coordinate down here. We go ahead and do a little subdividing. Let's see. 8's going to go there. So this is going to be 12, and this is going to be 4. And then we do 1, 2, 3, and then 5, 6, 7, and 9, 10, 11, and 13, 14, 15 at equal spacing, more or less. And now we have a scale where we can estimate the x coordinates, and then we do the same for the y. Subdivide the 32 down to 16, the 16 down to 8, cut this in half, it's going to be 24, and then we cut this in half, it's going to be 4, cut this in half, it's going to be another 4, which is going to give us 20, cut this, it's not 20, it's 12, cut this in half, it's 20, cut this in half, it's 28, and then we can not doing a real good job of this because you don't need to stand there and watch me or sit there and watch me do it all. You can do it yourself, but you get the idea. Okay, so now I think that the coordinates of this point seem to be about 13, 14, I'd say about 14.6, and the y coordinate is probably about 11.8 the way I look at it. Over here we've got about 5.7, and of course you can make your own estimates and you'll be able to see more clearly. I can see a little more information than you can here. Doesn't mean I'm all that close. And this is going to be about 27.3. Now whether those are good estimates or not, well, yeah, hopefully they're good so I can draw valid conclusions. Now we know that the equation of a straight line, okay, well, so got carried away in that T there, didn't I? The equation of a straight line, there are a couple of standard equations. The slope-intercept equation is y equals mx plus b, and I assume everybody knows this perfectly well. In the standard form, or the intercept form, and I'm not sure I'm even calling this, yeah, I called this a standard form. Actually, I think, okay, the intercept form is ax plus by equals 1. And I think a standard form is like ax plus by plus c equals 0. So any of these forms give you the equation of a straight line. You could solve any of these equations for y, and if you did, you would have y equals some multiple of x plus some number. In other words, you would have the slope-intercept form. Okay? And you can rearrange this equation into this form, or this equation into this form, or this equation into either of these forms. I'm not going to go through that. Hopefully your algebra is up to that, because it's important to have that kind of flexibility in your, algebra's bag of tricks. But there we have it. Okay? Now I'm going to use the intercept form to get the equation of my straight line. I could have used the slope-intercept form, could have used the standard form. It would work out in any of these ways. And the way I'm going to do that is I'm going to say, okay, well, there are two numbers that I need to figure out. I need to figure out a number for A and a number for B. If I was using the slope-intercept form, I'd have to figure out a number for M, a number for B. For the standard form, well, I'd have to figure out a number for A, a number for B, and a number for C. So it seems like there are three things I've got to get, but one of them is dependent on the others. So anyhow, in this form and this form, it's very clear there are two parameters, two numbers that I have to determine, and then substituting those numbers gives me the equation of the line, either in this form or this form. So using this form, okay, so I'm going to take the first point, and I'll do my point first, second, left to right. But I could call this first, I could call this second. It's the first one I wrote down, wasn't it? Okay? Anyhow, the first point is 5.727.3. Well, that implies that .7 times A, because it's A times X, the X coordinate is 5.7, substituting that for the X, and of course I put the number in front of the variable, commutative law allows me to do that, and then plus 27.3B equals 1. Okay, and the second point, well, 14.6 is the X coordinate, so I'm going to get 14.6A plus 11.8B equals 1. Now there are different ways to solve the equation, and hopefully you've solved simultaneous equations. You know that, for example, if I multiply the first equation by 14.6, then the coefficient of A will become 14.6 times 5.7. If I then multiply the second equation by negative 5.7, the coefficient of A is going to become negative 5.7 times 14.6. So that if I continue multiplying the rest of the equation out, by this one by 14.6 and this one by 5.7, when I add them, the A's go away, and then I just have some multiple of B equals some number. And it's real easy to solve for B. Then I can take that value of B, plug it back into either equation, and get my value for A. Now hopefully you recognize this. Okay. If not, I'll do a couple of examples of simultaneous equations, but I'm not going to do this one because these numbers are a little nasty and you have to use a calculator to do those multiplications and so forth. Another way to do it is solve this equation for A. Subtract the 27.3b from both sides and divide both sides by 5.7, and then you have an expression for B. Plug that in for B. Now this expression for B is going to be in terms of A, because B is going to equal some multiple of A and some other number. So when you plug it in for B, you don't have B's anymore. You've eliminated B from the two equations, solving this equation for B. I think I said all that right. So if I want to solve this for B, I subtract 5.7a from both sides, divide by the 27.3, take that expression, replace B with that expression, because that's what B is equal to now, and solve this equation for A, because this will just be an equation in A. Now it's a little nasty with the numbers, but that works. Okay? So we solve and we get values of A and B. Okay? Now, I don't have the exact values, but I could do an estimate, and I'm hesitating because I don't know if I want to do that. I say maybe it's about what? Okay, maybe about A equals, and I'm not going to bother explaining how I get this, 0.05. B approximately equal to about 0.03. Then the equation is ax plus by equals 1, 0.05x plus 0.03y equals 1. And there's one form of the equation. Another form of the equation, we could solve this equation for y. So I'll say, or solving for y, you would get y equals negative 1.7 approximately x plus 33. Now that would mean you have a slope of negative 1.7 and a y-intercept of 33. Well, the y-intercept looks a little higher than 33. A slope of negative 1.7 may be about right. It looks like if you extend this graph out where it intersects the x-axis, you get something like, oh, it looks like maybe about 22 here. Okay, getting a little sloppy, but if this number is 22, then 33, well, if you just do a fundamental triangle from the y-intercept to the x-intercept, it's going to have a rise of about negative 30, looks like more like negative 35 or something like that, and a run of 22. Okay, so what we have is right triangle, the negative 35 here and a 22 here, and the slope is negative 35 over 22. Well, 35 over 21 would be, excuse me, 5/3. That's about negative 1.6. Since I'm doing rough estimates, that kind of works out. Okay? And a y-intercept of 33, maybe it's closer to 35, but you see that this equation is fairly close, and this equation is therefore fairly close, because this equation, if you solve this exactly for y, you get 1.6 repeating, about 1.67, slope of negative 1.67x, and you do get 33 1/3. So if you solve that for y, you can see that it comes out close to this, and you can see that that's fairly consistent with the equation this straight line has. Now I'm assuming you're familiar with straight lines, assuming you're familiar with simultaneous equations. I'll digress here and solve a couple of simultaneous equations with easier numbers just to make sure that we understand the process of solving a simultaneous equation. And I'll probably solve it in 2 or 3 ways just to be sure we understand how it's done. Then we want to talk about what we would do if we wanted to do a quadratic model. We had 3 points in a graph. There's a quadratic function, a function of the form at squared plus bt, or ax squared plus bx plus c, that goes through those, that fits those 3 points. And as you might or might not know, you should know if you've had an analysis course, to graph that equation is a parabola.